Hello and welcome to Ellis Patents. Ellis Patents was founded in York in the early 1960s and is a specialist manufacturer of cable cleats designed for withstanding short circuits in low, medium and high voltage installations. In recent years, Emperor, Vulcan and Alpha cleats and Centaur saddles have been launched following an intensive program of development. Ellis Patents cleats can now be found in power generation and distribution, oil and gas, both onshore and offshore, petrochemical and heavy industrial installations worldwide. In-house design facilities enable Ellis Patents to maintain the company ethos of opportunity through innovation. Short-circuit testing is one method it uses to push the boundaries of cable fixing technology even further and meet the changing demands of its customers. The purpose of this video is to demonstrate the reasons for cleating power cables, and the footage we're going to show you is taken from a series of tests that form a regular part of Ellis Patents' product development program. In recent years, Ellis Patents have carried out over 130 separate short-circuit tests and have had their products tested and independently witnessed and approved in the UK, Holland, Germany, America and Russia. The forces experienced by cleats in short-circuit conditions are a function of short-circuit current, cable diameter and cleat spacing. All three factors have to be considered when determining how aggressive a particular test is. The first two tests show the difference between an installation which is inadequately specified and a correctly specified installation. Firstly, we demonstrate a typical installation where stainless steel cable ties are used on an installation with a relatively low short circuit level. This method of securing cables is accepted practice, but is obviously unsuitable for such applications. In the second test, the same type of cable installation is subjected to the same fault level. However, this time the cables are secured with an aluminium cable cleat every 600 mm. Despite the increased spacing between each fixing, the test is a complete success and the cables are protected during the fault. Triplex is difficult to cleat with standard product because of its twisted configuration. In response to this problem, in the next test we used a combination of two products, an improved design 2-hole clamp and a special surround for fixing triplex cable. This test provided Ellis Patents with its first short-circuit test certificate for an all-plastic product. The next clip demonstrates the strength of Ellis Patents' Vulcan Plus cleat and challenges the view that basket tray is not suitable for mounting power cables which may be subject to fault conditions. Single core cable was laid in trefoil formation and secured to wire basket tray. Both cleats and wire basket successfully passed a rigorous test due to their inherent strength and flexibility. Continuing the theme of short-circuit testing on different types of structure, the next test used GRP ladder. 3 Class 5 conductor cables were fastened to a flexible GRP ladder structure and subjected to a fault of over 235,000 amps. Despite a calculated force of over 60,000 newtons per cleat, the test was a complete success. As every installer knows, the conditions on site will often influence the exact installation method. In the next installation, Emperor cleat is fixed with a protective intermediate strap at every midpoint. This fixing method allows the installer to safely secure the cables even when the site conditions may not have the necessary ladder or structure fixing points to allow a fixed cleat installation. The next clip shows another example where accepted custom and practice for securing cables is inadequate. Here, a standard single core cable installation is subjected to a moderate fault level. The mode of failure indicates that this level of specification would have serious consequences in the event of a fault. If we now compare a properly specified installation, even though the cable cleats are fixed at greater centres, when subjected to a similar fault they perform superbly well. Complete protection is provided for the installation, surrounding equipment and personnel in the event of a fault. Next, we'll demonstrate the difference between a tensile test carried out in a laboratory and an actual short circuit test. The prototype cleat you'll see have been successfully tested in the laboratory, and the short circuit forces were calculated to suit the results of the controlled test. The dynamic forces of an actual short circuit occur within 5 milliseconds and act upon the cable cleat within this time. The test proves that the only sure way of determining a cleat's adequacy is to carry out live short circuit testing. And finally, we disprove another commonly held perception that multi-core cable restrains the forces of a fault within the cable itself. A 3-core 95mm square unarmoured cable is subjected to a fault level found on many standard commercial specifications. Due to the fact the 3 cores of the cable are surrounded by an outer jacket, it's often assumed that cable ties will be enough to restrain the forces of a short circuit. This is clearly not the case, as you can see here, and careful selection of the appropriate cleat is still of paramount importance. Ellis Patents uses results from tests such as these to continuously improve its existing products and to develop new ones. From our wide experience in the test laboratory and in the field, we're happy to provide advice on the most appropriate cleat and cleat spacings for given cable diameters and short circuit withstand requirements. If you'd like any further information, our contact details can be found on our website. We hope that you found this video informative, and we also hope that we've demonstrated our commitment to the company tradition of creating opportunity through innovation.